Hello everyone. So today we are going to discuss about Woodward-Fieser rule for calculating lambda max in alpha beta unsaturated aldehydes, ketones, carboxylic acids and esters. So for calculating lambda max, we are taking the total 11 examples so that after watching this video, you will be able to calculate lambda max in each type of compounds. So let's start. So in the Woodward-Fieser rule, they have given this basically values, uh, some base values and some increments. So basically, in this lambda max, we are calculating this is for pi to pi star transition. So here, these are the base values, and these values are given in the ethanol. So ethanol is the solvent. So suppose that there is one alpha beta unsaturated ketone, and if it is acyclic or cyclic, if it is cyclic then six membered. If it is six membered means like alpha beta unsaturated like cyclohexanone. So the value will be 250 nanometer, and the base value or parent value for the alpha beta unsaturated ketone, cyclic ketone, but this is five membered ketone means cyclopentanone derivative, that is 202 nanometer. And the base value for the alpha beta unsaturated aldehydes, so it's the value is 207 nanometer. And for alpha beta unsaturated carboxylic acids or carboxylic esters, the value is same, 197. These values may differ with 1 or 2 nanometer. So in different books, these values may be different, but don't worry. So the answer will not differ the 1 nanometer, 2 nanometer or so, right? Okay, so and the increment value in the earlier video, that was for the calculating lambda max in the diene system, conjugated diene system. So in that, generally there was no alpha beta gamma delta positions, so that's why there was only one value for different alkyl groups and different functional groups. But here, because this is carbonyl compounds and alpha beta unsaturated, so here at different positions they contribute the different value. Like we can see here, the alkyl group or ring residue. Here, if it is alkyl or ring residue is present at alpha position, the value it will contribute is 10 nanometer. If it is at beta position, it will contribute 12 nanometer. At gamma position, it will contribute 18 nanometer. In some books, it is written like 17 nanometer. And here at delta also, this will contribute the same value, 18 nanometer. And if this alkoxy group is there, then the value is different. Here you can see here again the 35 nanometer if it is at alpha position, 30 nanometer at beta, 17 nanometer at gamma, 31 nanometer as at delta positions. And if this is OH group, then at alpha it will contribute 30 nanometer, at beta this is 35 nanometer, at beta 30 nanometer, and gamma at gamma also 30 nanometer. If it is at delta, that it will contribute the different value, more value, that is 50 nanometer. In case of chlorine, if it is attached with a conjugated system, then definitely it will contribute a 15 nanometer at alpha position, and at the rest of the position it will contribute 12 nanometer at beta, gamma, delta and so. In case of bromine, it will contribute 25 nanometer at every position, but at beta position it will contribute the more position, that 30. So 25, 30, 25, 25. So in case of the acetate group, this acetate group, and it will contribute the same value like 6 nanometer, 6 nanometer, 6 nanometer, 6 nanometer at alpha, beta, gamma and delta positions. And if it is the thioether, then at beta it will be at beta position it will contribute the 80 nanometer. And if it is NH2 group or substituted NH2 amine, means monosubstituted disubstituted amine, so that will contribute at beta position, that is plus 95 nanometer. Other things are like exocyclic double bonds. We have already discussed in the earlier video. That was for the conjugated dienes. You can watch that video for what is the exocyclic double bond. We have explained there. So exocyclic double bond, they will contribute the same value, that 5 nanometer. And double bond exocyclic to two ring, if same double bond is exocyclic to two rings, then it will contribute the double value 10 nanometer. If double bond extending conjugation, extra double bond is there, then it will contribute 30 nanometer. And if the second double bond, if there is this extra, double bond extending conjugation, and if it is homoannular with the first double bond, so definitely it will contribute plus 39 nanometer in addition to 30. So 30 it will contribute because of this is extending double conjugation, and 39 if it is homoannular. If it is heteroannular, then this will not contribute any extra increment. Now, in case of dienes, in the earlier video, we have seen that there was a minimal shift, or you can say the negligible solvent shift. So that was not considered, right? If you are taking, whether you are taking the lambda max in water, methanol, chloroform, and different solvents, the values were same, almost same. So that was negligible. But in case of this alpha beta unsaturated carbonyl compound, there is a significant change due to the solvent change, right? So this is called the solvent shift. Solvent shift, if we are taking water, because those values were in the ethanol. So if we are taking water, so this will, in the polar solvent, this will contribute plus 8 nanometer. And if it is methanol, so in the methanol the value will be same as was in ethanol, so there will be no contribution. And if it is less polar solvent in comparison to ethanol, like chloroform, so the value will be subtracted like 1 nanometer. If this is dioxane, then there will be subtraction of 5 nanometer. If this is ether, then there will be subtraction of 7 nanometer. If it is normal hexane or cyclohexane, the value this will be subtracted is same, that is the 11 nanometer. This is the solvent shift. Now, this is the first example. We have to calculate lambda max. So here, first of all, we have to identify the system, and first of all, we have to write the base value or parent value. Base value for what system? System is here. This is, you can see this is carbonyl group, ketone. This is beta. This is alpha. So here, this is alpha beta unsaturated acyclic, this is not cyclic, acyclic ketone. So this will be, value is 215 nanometer. Now we will add increments. Increments will be like any other thing. So first of all, we will mark this conjugated system here, and the system we have marked, this is the part of ketone because this is alkyl group. If this is not alkyl hydrogen, that will be aldehyde group. So this alkyl group is the part of ketone. So this for this value is included in this base value. And alpha beta, this alpha beta unsaturated, this double bond is also contributing here in the base value. Now other things will contribute in the increment, like this is alpha, this is beta. So there is no alpha alkyl or ring residue, but at beta there are two cuts. So it means there are two alkyl groups. So two beta alkyl groups, because these are at beta position. So these will contribute the double value because there are two alkyl groups. So one at the beta position contribute 12 nanometer. So double value of 12 will be 24. So this will contribute plus 24 nanometer. Is there anything else? There is nothing else. No extra double bond, no case of exocyclic or double bond, because this is not cyclic. So this will be the value. And here the lambda max calculated and in what? In ethanol. So that will be here total 9 and this 3, 239 nanometer. This will be the calculated lambda max. Now this is the second example, and this is the different case. Here the group is aldehydic group. So the base value for the, this is alpha, this is beta. So this is alpha beta unsaturated uh, aldehyde. Aldehyde is always a cyclic aldehyde, or you can say aldehyde just, right. Okay, alpha beta unsaturated aldehyde, the value will be here, that is 200, this 7 nanometer in the aldehyde case. So here now we will mark this conjugated system here, and here this is the part, aldehyde group is the part of this base value. Now at alpha position you can see there is one alkyl group, so increments, one alpha alkyl group, and that will contribute at alpha plus 10 nanometer. At beta there are two beta alkyl groups, so at beta position it will contribute 12, double value because there are two in number, so total 24, and there is nothing else. So this will be the like calculated lambda max in ethanol, because these values are in ethanol. Total 1, this is 4 to 41 nanometer. This will be the calculated lambda max. Now this is another case, a different case. Here you can see this is a carboxylic group. This is the alpha beta unsaturated carboxylic group, carboxylic acid. So here base value will be for the alpha beta unsaturated carboxylic acid. So this will be 197 nanometer, and here the contribution means increments values for different groups. So firstly we should mark this, the conjugated system here. So you can see at the alpha position there is no alkyl group, but at beta position there are two beta alkyl groups. So it will contribute 12 into 2, total 24 nanometer. There is nothing else. So now we can sum up them. So they're calculated lambda max in ethanol. This will be total, this 11, this is 12, and this is 221 nanometer. Now this is the example of alpha beta unsaturated carboxylic ester. This is the alkyl group, so this is ester. So base or parent value for the, this is alpha, this is beta, so this is alpha beta unsaturated carboxylic ester. So the value is same as it was in case of carboxylic acid, so 197 nanometer. And here increments we can add this, there is nothing at alpha position, but at beta position there are two alkyl group. Firstly we should mark the conjugated system here. So you can see at beta there are two cuts, so means there are two alkyl groups, two what, beta alkyl groups, two beta alkyl groups. It will contribute double value of the increment, that is 12 into 2, total 24 nanometer. and there is nothing else. So here we can sum up as a calculated lambda max, and that is in ethanol. We are mentioning it here as the solvent because there you may be asked to calculate lambda max in different solvents. So this is these values are for the ethanol. So these are we are mentioning here in ethanol. So this 11, this 12, and this one 221 nanometer again. So this will be the lambda max calculated. Now this is the case, okay, that we have to calculate lambda max in hexane. Here it is mentioned that lambda max is asked in hexane, not in ethanol. So firstly we will calculate in ethanol, and then we will add this solvent shift, right? So here you can say this is the cyclic. So this is cyclic ketone and six membered. So this is alpha beta, but yeah, this is cyclic ketone is of this, but yet double bond. This double bond is not or not the part of the ring. So that's why this is, you can say, the cyclic. So here this is alpha. This bond is not the part of the ring. So here this is the basically alpha beta unsaturated ketone. This is the base value for alpha beta unsaturated acyclic ketone, that is 215 nanometer. That is there is a confusion that why we are considering, although the value is same for the acyclic ketone as well as the cyclohexanone, but this is the cyclohexanone, but this double bond is not the part of the ring. If it was, if it were the part of the ring, that definitely would have, we would have written here the cyclic six membered ketone. So this is, we are considering is that a like a cyclic ketone. The value is same. And increments we can take here at alpha position. This cut is representing the ring residue. This is the part of the ring. So this is one alpha ring residue. So that will contribute 10 nanometer at alpha position. At beta position there are two ring residue, two beta ring residues. So double value 12 into 2 at beta position, total 24 nanometer. Is there anything else? There is no extra double bond, but yes, this double bond is exocyclic to two rings A and B. Suppose that this is A ring, this is B ring. So one double bond exocyclic to two rings. So this will contribute to the double value, means double value of plus 5, that will be plus 10 nanometer. Is there anything else? There is nothing else. So we will sum up all them. Then this will be lambda max. This is calculated in ethanol. This will be like 5 and 4, 9, 1, 2, 4, 5, 259 nanometer. This is in ethanol, you can see here, but we are asked to calculate in hexane. So we will add, like here we will add the solvent shift. Solvent shift. So solvent shift for hexane. So that will be minus 11. So now this lambda max calculated in hexane will be total 248 nanometer. So this is the lambda max in hexane. So we can calculate lambda max in different solvents. Now this is another example of different kind of compound. Here you can see this is the ketone, and this is alpha, this is beta, this is 5-membered ring, but this is not cyclopentanone. So here base value will be for the alpha beta unsaturated ketone, or this is acyclic ketone. This is acyclic, this because the ketone and double bond both are not the part of the ring. So this is acyclic ketone and value is 215 nanometer. Now the increments you can see there is if you mark this, this is a part of like this. So this is the part of the ketone. We have the base value, but this is alpha at alpha. This is the ring residue. So one alpha ring residue. What alpha ring residue that will contribute 10 nanometer, and at beta there is one beta ring residue, one beta ring residue here. So this will contribute plus 12 nanometer, and one beta alkyl group, one beta alkyl group. So this will also contribute plus 12 nanometer. And is there any other thing? Yes, there was Cl, but this is not on the conjugated system. Conjugated system start from here and this goes up to this carbon. So this is not at the conjugated system. So this will not contribute anything, no increment because of the Cl. This is out of this conjugated system. So here, and there is no exocyclic double bond, and now we can sum up them. And now the lambda max calculated in ethanol will be 9 here for 249 nanometer, 249 nanometer. Now this is another example of like cyclic ketone. Here this is the cyclic ketone, a 6-membered ketone, because here the ketone as well as the double bond is the part of the ring, same ring. So here base value for the, this is alpha and this is beta. So this is conjugated system is alpha beta unsaturated cyclic and basically 6-membered ketone, means part of the cyclohexanone. So the value is same, although 215 nanometer. And increments will be like we will just mark this conjugated system. This is the part of ketone, but here at alpha there is nothing else. The beta there are two, one alkyl group, one, so one beta alkyl group is there, that will contribute total 12 nanometer, and one ring residue, one beta ring residue, that will contribute here again 12 nanometer. And there is nothing as this alkyl group is not under the conjugated system, and there is no exocyclic double bond. So this will all, now we can sum up them, lambda max, and this is calculated lambda max in ethanol, that will be total here 9 and 3, 239 nanometer. Now this is the example of like cyclopentanone. Here the carbonyl group and the double bond are in the same ring. So here base value for this is alpha, this is beta. So this is alpha beta unsaturated, or this is cyclic, and in the cyclic 5-membered and ketone. So for that the value is 202 nanometer. This is the base value for the cyclopentanone, alpha beta unsaturated cyclopentanone, the 5-membered ring. So here increments, in the increments just we will mark the conjugated system here, And you can see here, this is the part of the base value here. And at alpha position, there is one alpha alkyl group. Alpha alkyl group that will contribute 10 nanometer. And beta, at beta position, there is one ring residue. Yes, this is no, not ring residue. This is the here ring residue. This is the part of ring. So this is ring residue. So here one beta ring residue. So that will contribute 12 nanometer. And at beta position, there is one functional group, that is acetate group. So that will contribute at alpha, beta, gamma and delta the same value, that is the 6 nanometer. So we will, but this is not attached on the conjugated system, so this will not contribute anything, but this will contribute. And there is nothing else, no extra conjugation, no exocyclic double bond, so we can sum up them. And here lambda max calculated in ethanol will be 2 and 4 6 10 2 3 230 nanometer. This will be the lambda max calculated. Now this is the another example. Here the two rings are fused here, and this is the cyclohexanone. So base value system is alpha. Here this is alpha, this is beta, and this is conjugated, this is gamma, and this is delta. So conjugated system is up to this. So you can just mark this. This is the conjugated system we have marked. So this is alpha, beta, unsaturated, and cyclic 6 membered. In the cyclic, this is 6 membered. Ketone, this is the system. So base value will be 250 nanometer. And now increments will be, you can see this is the part of the system ketone, because this is a part of ketone. At alpha there is nothing. At beta there is, this is, now this bond will be the part of the conjugated system, so only this is the extra bond. So here one beta ring residue, at beta position there is one beta ring residue, it will contribute 12 nanometer. And at gamma, so at beta this is the ring residue, at gamma this is the ring, this is the kit, this is the one cut. So this is one gamma ring residue, that is also part of the ring, so ring residue, and that will contribute 18 nanometer. And at delta this is one cut, so this one cut will means there is ring residue, one delta ring residue, this will contribute total 18 nanometer, right? And I think this is all about, but yes, but there is one extra double bond, this is gamma delta. So this is one double bond extending conjugation that will contribute 30 nanometer. So now this is second double bond is not homoannular to the first double bond, this is heteroannular, so this will not contribute the further. And now we will check whether any double bond is exocyclic. Suppose that this is A ring, this is B ring. So you can see this double bond is exocyclic to the B ring, and this double bond is exocyclic to the A ring. So there are two exocyclic double bond, two exocyclic double bonds. Two exocyclic double bond, it will contribute double value, so plus 10 nanometer. Anything else? I don't think there is anything left out. So now we can sum up them. Lambda max here calculated in ethanol and the value will be 5, then 7, 15, 23, 2, 3, 4, 5, 6, 7, 10, 303, 303 nanometer. Now this is the another example. The two rings are fused. Here you can see the this is example of alpha beta unsaturated, alpha beta and gamma and delta. So here we can mark this ketone, cyclic ketone. This is the marking. So base value for the alpha beta unsaturated and cyclic, what membered? 6 membered. This is 6 membered ketone. This is the example of ketone. So 250 nanometer will be the base value. Now the increments will be right at alpha there is no alkyl group, at beta there is one cut, it means one beta, and this is the part of the ring residue. So that will contribute 12 nanometer. And now at gamma there is one ring residue, one cut, so one gamma ring residue, it will contribute 18 nanometer. And at delta there is one cut, so it will contribute one delta ring residue will contribute 18 nanometer. Now is there anything? Yes, one double bond extending conjugation, one double bond extending conjugation. So this will contribute 30 nanometer. And now the second double bond is carbon-carbon double bond. The second carbon-carbon double bond is homoannular to the first double bond with. So means second double bond is homoannular with the first double bond. So additional increment of 39 nanometer will be added here. Now exocyclic double bond we have to check whether there is any other exocyclic double bond. This is A ring, suppose that this is B ring, so this is exocyclic to the B ring, this double bond is also exocyclic to the B ring. So total 2 exocyclic double bond, 2 exocyclic double bonds. To exocyclic it will contribute a double value 10 nanometer. I think there is nothing else, so we can add them. Lambda max here calculated in ethanol solvent, ETOH. Now value here you can add 5, 7, 8, 15, 23, 32, 3, 4, 5, 6, 7, 10, 13, 14, and this is 343. If I am not wrong, I think this will be the value. 5, 7, 15, 23. No, this will be 342 nanometer. This will be the correct. Now this is the other example. In this case you can see here there is the cross conjugation. This is the example of cross conjugation. Such type of example is also discussed in the diene system in the earlier video, you can watch there. So here you can see this is the ketone, and at both the side there are double bonds. So either we can this is also alpha beta unsaturated, and this is also alpha beta, alpha, and this is beta, this is also alpha and beta. So wherever there is such type of situation, when both the sides there are two double bond, this type of conjugation is called the cross conjugation. Means these are not in continuity, means both are at different side. So in the continuity, if both the double bonds are in the same side, that is the normal conjugation. But if such type of conjugation is there, that this is called the cross conjugation. So at a time we can choose only one. So we will choose that side of this conjugated system which will contribute more. More means that should be highly conjugated, that should be highly substituted. So if we compare these two double bond, you can see at alpha there is no alkyl group in both the systems, but at beta you can see here there is this is 2. At beta there are 2 ring residue, but at this there is only 1 ring residue. So, and yes, so this will contribute more because this is highly substituted, more substituted in comparison to this. So we will consider this conjugated system, means we will consider, we will mark the conjugated system, this one. We will neglect this, we will consider this, or we can consider only one, not both. So here, this is the example of alpha, the base value for alpha, beta, unsaturated, and this is cyclic, and in the cyclic this is six membered, and ketone, this is ketone, so base value will be 215 nanometer. And here increments in increments, we can add at alpha there is no alkyl group, and at beta position there are 2 ring residue. So 2 beta ring residues will contribute double value 12 into 2, so total 24 nanometer. And is there anything else? Yes, you can see here this is cyclic, so this is A ring, suppose that this is B ring, and this double bond is exocyclic to the B ring. So one exocyclic double bond. So one exocyclic double bond will contribute 5 nanometer. Is there anything else? I don't think there is anything else, because these other rings and the third ring, they will not contribute this alkyl group because these are not the part of the conjugated system. So we will contribute, we will add only those value of those which are the part of the conjugated system. So here we can sum up them, and lambda max will be, we have calculated in ethanol solvent, that will be 5, 5, 10, 14, 1, 2, 4, and 244 nanometer. This will be the value here. And this was all about, and now the assessment time. Now this is your turn. Now calculate the lambda max for this compound and write your answer in the comment box.